All right, guys, here we go. We are on the last class of this semester. So the plan here is that we are going to add a third motor to our robot arm. I'm going to start with making my robot arm stronger. So if you haven't done that yet, this will be a good time to do it. I'll actually show you how I do mine. So let's take a look. So right now you can see my robot arm is a little bit loose, like it's not staying up like that, and it's probably because this foam here just kind of loses its stickiness over time. So try to stick it on there. It helps a little bit, but not too much. So let's use some tape, and let's see if we can get this taped on there. Help it out. Now here's something to keep in mind. Okay, if we put tape like this, and if we tape the pencil to the motor body like that, what's going to happen is that because the pencil is stuck to the motor, it's not going to be able to move. So we want to make sure when we tape, we only tape to the coupling, okay, the white part. So how do we do that? We kind of need to get a little bit, let me take this off. The best way is to kind of get underneath it. Okay, so we're trying to tape it like this. So what I do is take my tape and go underneath like that. Remember, we're just touching just the propeller and kind of wrapping it. So that's going to make a pretty strong connection right there. Okay, and I'll do it with this second piece here. Okay, just bring it underneath like that. I'll hold it up so you can see it. Kind of wrap it. Make it nice and tight. So that's probably the best way to get it nice and sturdy. Okay. Maybe I want it a little bit stronger, so add a couple more pieces of tape. Just give it some extra strength here. Okay. All right, I think that's good. Now this one's solid. Now this guy right here is not very solid. So let's see what we can do with that one. This one's easier to tape. We just need to get the body onto the pencil. Now, the challenge here, so yeah, we could tape it, but you know what would be even better is if we get something like some cardboard. This is just some scrap cardboard, and then what we'll do is create like a couple splints. And it's something that you would use if you sprain your arm or something and you want to keep it in place. So we want to make sure that this motor here doesn't wobble, right? So we're going to put two splints, like one on this side and one on that side. And I'll do that with cardboard. So you guys can try that at home. This I just grabbed from, it could be a cereal box, whatever. Even a bunch of thick paper, I probably could do it too. So I'm just going to cut a little bit here. Doesn't need to be perfect. Okay, that's probably good. Need two splints, right? Okay, I got two splints there. Now, this would be way too big, because then, again, we always got to be aware of the coupling. We don't want to block the moving part. So probably just from the bottom of the pencil to about right there. So I'm going to cut this even smaller. So I probably only need one of these. So I need about this long. There's one. Okay. Actually, actually guess that was 2 pieces, so that's fine. Okay, so what I'll do now is put one on this side, a splint here, and then a splint on this side. All right, and then I'll tape it all up. So maybe I'll do one side first. I'll first tape this side. You know what? Now that I'm thinking of it, let's get this thing really strong. So part of this process, right, is you got to think about where can I tape to make it stronger, but then at the same time not get in the way of the moving part. So I just realized, well, what if I go something like that, right? So that should help. Okay. So that should help a little bit attach the motor to the pencil in this direction. Let me just put another piece on the other side. Now that one piece is not super strong, but what's going to happen is that when I put a bunch of all these pieces and all the support, it should become pretty strong. Okay. Put one on this side. Again, be careful not to get in the way of the moving parts. Okay, so honestly, even like that is not bad. But what I'll do now is put in these splints now, and it's going to be even better. So I'll put one on this side. And we'll see when we start working with the real robot arm. You'll see how it's designed, and as you know, as we design the parts, all the gears and what type of plastic pieces need to be attached to the different parts. The concept is the same: is that we want to make sure things can be fastened, strong. Very strong, so that it doesn't fall apart. Okay, so let's put another splint. This is already getting pretty strong. I probably don't even need the second splint, but I'm going to do it for extra credit, you know, because I don't want my arm to fall apart. Okay, here we go. One more piece of tape. So you guys could do the same thing as me. First put on those 2 couple pieces, and then put on the splint. Okay. Now check it out. Pretty solid. Here, let me plug this in. Yeah, pretty solid. It's not wobbling at all. Okay. So now, and I'm gonna have to stabilize this later. Maybe I'll put a weight on it to keep it down, or maybe put another piece of foam on the bottom here. This one's a little worn out to stick it to the base here. Now, this one here, right here, so the arm motor right now is attached to this second pencil. I'm going to take a third motor, and that's what we're going to do today, and we're going to attach it to this one. Okay, and that's going to be 3 motors. Now it's going to start weighing the whole thing down. So what we want to do then is let's make sure we fasten, put some tape on this pencil and this coupling as well. So right now this thing still pops off. I didn't put the screw on. I'm going to see if I can get away with that to see if it still holds without the screw. For you guys, if this pencil starts falling off, you might want to put the screw in there to give it some more strength. As I mentioned in the previous class, when we start working with the plastic parts, all these attachments, it's not going to be tape, it's going to be all screws. So everything will be nice and tight. All right, so we've got this going. So same thing. Let's put tape on both sides, okay? And make sure we stay out of the moving parts. So whenever you're taping, just take a look and just say, okay, whatever I'm taping, does it still allow the motor to do what it needs to do, right? We don't want to block it at all. Okay, here we go. Yeah, you know what? This thing comes off, so I can actually take it off and tape. It's pretty convenient actually, and then put this back. Okay, let's make sure I'm calibrated, that I put it at the right spot. Give it a second here. Oh, actually I'm a little bit off. Let's see if I can fix this. So it should be, right now, it should be like that. Again, that's the benefit of not screwing it in, because then you can adjust it if you need to. Yeah, perfect now. Okay, I'm going to turn this off. All right, so now what we're going to do with this third motor. Well, first thing is, you see right now our motors are all facing like this, right? This one's facing like this. This one's also facing like this. So what that means is that we both have this sweeping motion. We have this sweeping motion on the base motor and also a sweeping motion on the arm motor. They both sweep from side to side, okay? What I want to do for this third motor, and that's where things get interesting, I want to create a different type of motion with this third motor. I want to actually create a motion that goes this way, so that I'm actually going to like kick something. So what I hope to do with this 3-motor robot is to actually make a robot that can stand somewhere, and I'm going to have it kind of retracted like this, okay? So what it should be able to do is move out to the max extension, and then be able to kick something on the table. And hopefully kick it off the table. So if that's the case, here's the first kind of thinking process here. So I'm going to put this coupling on for now. I'm not going to screw it in. Again, once you, for you can screw it in once you know where you want everything. Do I put my motor, if I want it to kick like that, do I put my motor like this? All right. So if I put it like that, it would be aligned with both the other two. So that's not the motion, because that would be another kind of windshield wiper motion. I want it to kick, so what I need to do is turn it like something like this. Okay? If I turn it like that, then it can move in a kicking motion. All right, so this is the first time we're going to be putting a motor on. And, actually it could be like this too. That will also give a kicking motion. So let me first, I'm going to put this guy on there. This will be my foot, I guess. Let's see. If I put my motor like this, and this is the kicking, I'll put the eraser. Let's put the eraser down about that high, so about there. All right, so you can find, if you don't, pencil or a pen, and just go ahead and find the right length. So we want to make it, the right length would be so that it kind of reaches the table, but not too long, because if it's too long, I get stuck, right? And if it's too short, it won't be able to kick anything. All right, so kind of get the rough height. It doesn't have to be perfect, okay? But mine is probably around there is a good height. Get some tape and do our typical thing of taping the pencil to the coupling, okay? All right, again, I didn't do the screw, so it popped off. It's even easier to do this. All right, that one, and then this one right here. All right, now I'm gonna put it on. And actually, I realize maybe can't tell by the angle of the camera, but I might be a little short, but let's see what happens. Okay. All right. So now, how do I get this on there? Well, why don't I use a stick foam? So I could put a stick foam to connect this to this, and then I'll use some tape to make it stronger, and then I think we'll be able to start trying this out. All right, okay, so I got my sticky foams here. Let's go ahead and take this and put it right here. Wait, no, I want it to go like this. So put it here. Let's put this back. Okay. And then let's stick it on. Okay, things are looking interesting. All right, 3-axis arm, and then let's put some tape on it. Get this thing nice and strong. And again, I'm careful not to tape any moving parts. Right? It's probably a good idea to put it on both sides. All right. Okay, so here is my robot arm. Now you see, it's kind of hard now because, let's see, because it's so heavy, it's hard to kind of keep stable. So what I'm gonna do is I'm gonna put some stick foam here. This one's totally worn out. I'm gonna put maybe two pieces here. Okay, maybe make it a little bit stronger and stick it to my table. Should help. Let's see. Okay. Okay, I realized that this one is a little bit crooked. See, I should have been more careful, but let me see if I can bend it a little bit. Okay. All right, we'll see if we can get there. This top one's a little bit crooked, but we'll see. All right, let's go ahead and this third motor, I'm going to connect it to pin number 10. So going down here, you're just going to go to column number 10 and plug this guy in. You know what? 10 is covered. I meant to say 11. So it's going to be on number 11, okay? Pin number 11. Okay, this third motor is on pin number 11. Okay, let's see if we can program this thing. All right, so going to the code. Let's see what we got here. All right, we have a servo motor, we have a base motor, we have a arm motor. All right, let's add one more motor, which is going to be the leg motor for kicking. Okay? And I'm going to say you got to attach to pin 11. And then, yep, let's do that. So then also leg motor dot attach 11. All right. And for now, let's just move this one. So I'm going to comment out the loop stuff. And let's just say, let's do leg motor dot write 0. Let's see what that does. So it should move this right here. So this is my third motor here. Oh, gotta plug in. All right, hold on. That was the old code on there. Okay, not sure if we could tell what it did there, but let's try again. I put 0. Let's move it to 90, and we should look for this motor right here to move. Okay, that moved. So 90 is like that. So 90 moves that way. I want it to, let's see. So if I want this pencil to be parallel to this pencil, so they're kind of like flat like that, I'm guessing I need to go about 180, maybe 170. Let's see. What did that? You know what? What's it gonna do if I do 180? Okay, so I'm trying to get it to go exactly kind of even with this one. It's not getting there. So the good thing is I didn't screw it down yet, so I can just do that. Okay. So right now this is parallel with that one. All right, so I have 180 is that. Then if I do 90, I believe it'll move down. It'll move down and try to kick something. So let me do 90. All right, so that kicks something. All right, so Okay, so let me do this. I'm going to go 180. I'm going to bring it back. Okay, I have this cork right here, and I'm going to put it right here. Okay, I think I should be able to kick this thing, this cork, if I go to 180. Sorry, if I go to 90. Let's try. Okay, I almost kicked it, but I think I need to be, it's like a little bit off. So let me go back 180. Again, if my pencil was a little bit longer, or if I didn't position it so that it's so short, it'd probably be a little better. So hopefully yours is a little better. But let me move it like closer like this. I know the top-down view is a little bit hard to see, but here's the cork here. Let's do the 90. It worked. All right. So what I want to do now is I want to make a kick routine. Okay. So for me, my leg kick is 90, and my leg raise, like lifting up my leg, I'll call it leg lift, is 180, just so I remember. So I'm going to go ahead and make a, based on these notes here, I'm going to make a function that will be called kick. Void kick. And so what do I do to kick? I go leg motor dot right, which one is it? I do these 180 to lift up my leg. Okay, I'm going to delay, like, I think just 500 is fine, half a second. Then I'm going to do leg motor right 90, and then delay 500. Okay, so your first challenge will be write a function to kick and try it out. Okay, so I have this function now to kick. So here's what I'm going to do. I'm going to put it inside here, and I'm going to upload it. Okay, let's see what happens. It should, I think what it'll do is it'll lift up, it'll lift the leg and then kick. Okay, you can see it's trying to kick it. You can see the wine cork kind of wobbling a little bit. So you know what? Your second challenge, to write a function to kick harder and try it out. So how do I kick harder? Well, kind of in soccer, right? If you have a bigger range of motion, it'll kick a little harder, make the ball go a little further. So let's do a void kick hard. Oh, see, it actually eventually knocked it over. So I'm going to copy everything here. Except now, so this is to lift, right? And then to kick is 90, but if we want it to go even further, let's go all the way to 0. So there'd be a pretty hard kick. Okay? Let's, I'm going to kick, delay 1000, and then kick hard delay 1000. Okay, let's see what happens now. Okay. Okay, so right now you see it's just normal kick. It can't reach it. I think once I do the kick hard, it should be able to kick. So I'm gonna upload. Oh, I have a mistake somewhere. Let's see if I can find it. Line 42, is it? Oh, right here. Extra one. Okay, so I'm gonna kick, wait 1 second, kick hard, wait 1 second. Go. Oh, there we go. All right. So now you can have it kick and kick hard. Now, okay, so we're almost there, and then it's time to kind of just be creative, right? Now I want to get all three of these, 1, 2, and 3. All right, so here's my challenge. I want to move to 45 degrees. So the challenge is move the base motor to 45 degrees and then extend out and then kick. Okay, let's see if we can do this. So what I need to do then is I need to move my base motor to 45, right? That's this one. It's going to move to 45. Then I'm going to extend. So I think if I look at my notes, my extend is 140. So what I do is here, I'm going to put a delay so we can see the movement. So after I move the base motor, then I'm going to extend, where did it say? Oh no, extend, which is the same as arm motor dot write 140, delay 1000. Okay, so at this point, this arm motor should flip this all the way, this one all the way over there. Okay. And then I'm going to kick, delay, kick hard, delay. All right, so your numbers might be different from mine, but let's see if this works. Okay, I'm going to upload this. So what should happen is that it'll shift to 45 and then extend and kick. Okay, that did not work because I think I flipped mine. Okay, so earlier, you know how I moved this around? It seems like it's exactly opposite of what I want it to be. So that can happen. You know what? So this one's opposite. So I put 140. Let's put 0 to make it go the other way. All right, let me change that to 0. So again, these things can happen, right? If you move your motor or move your coupling, it can get thrown off. But we can always fix it. Okay, let's see. Extend. I think it's going to extend. Oh, this is interesting. Okay, you can. This is right now. This is 2. There. My this right here, this cable is so tight right now. So that can happen too. All right. So keep that in mind. If your noggin is too far, like if your noggin is too far away from the motors, it can actually, these wires can get caught. All right. I'm like barely there. So but it did work. Okay, so what I'm going to do is I'm going to add another routine to bring it all the way back to 180. So after it kicks and then kicks hard, I'm going to move the base motor dot right to 180, and then I'm going to retract it back, bring this back. So that would be so put a delay there, and then the arm motor. So I did 0 was to kick it out like that. So 140 should be to retract it back. Okay. Okay, so now it should do it and then come back. I also made another mistake here. Let's see. See if I can find it. Oh, arm motor dot right. There we go. Again, my cable got stuck. Okay. All right, I'm gonna turn it off for now. All right, so there you go. So I can fine tune this. What I would do is that you see there's so much tension on this cable right here. I would move the location of this, maybe if I put this over here, right, so that it wouldn't stretch as much. So go ahead and try this challenge, is that you would move the base motor to 45, extend out this arm, and then kick. And then what you want to do is take like an object and put it pretty far out there, like something like that. And have it so that you can only kick it if this thing extends out. And so that's the beauty of having many motors. If you want your robot arm to have more reach, what you need to do is have motors like this that are controlled by this motor, or motors like this controlled by that motor. The more motors you have and the more kind of extensions you have, the more complex and further reach you can get on your robot arm. Okay, so again, challenge 3 is move the base motor 45 degrees, extend out, and then kick, and then go back to 180 degrees. I guess to be more specific, and then move the base motor back to 180 degrees and retract. All right, so it's going to come out, extend, kick, and then come back to 180 and then retract back. All right, give that a shot. Should be fun, and then we'll chat more later this week. Talk to you guys later.